Hey everyone, and welcome back for another deep dive. Today we're going to be looking at AI in medical imaging.
Yeah,
It's a fascinating topic,
it is.
and it's one that I think is really going to be transformative in the years to come.
Absolutely.
And I'm really excited to have you here to kind of walk us through
Yeah, happy to be here.
all the ins and outs of this technology.
Absolutely.
So I was doing a little bit of research before this, and I was just blown away by some of the numbers.
Right.
I mean, the global AI market is projected to be worth over $1.8 trillion by 2030.
Yeah, that's a big number.
It's a huge number. And then you look at AI in medical imaging specifically, and it's expected to hit over 14 billion by
Wow.
2032. And that's not even counting the medical imaging software market in general,
Yeah.
which is projected to be worth over 11 billion.
Yeah, those numbers are pretty mind-boggling, but I think what's even more telling is the rate of growth.
Okay.
Medical imaging software is predicted to have a compound annual growth rate of 7.5%, which basically tells us that this is not just some passing fad. This is something that's really gaining momentum.
It's here to stay.
Exactly, yeah. And I think it has the potential to really revolutionize the way we approach medicine.
Absolutely. So let's break it down a little bit for folks who might not be familiar with this world.
Sure.
When we talk about AI in medical imaging,
Hmm.
what exactly are we talking about? I mean, we're talking about like robots doing surgery or
Not quite robots wielding scalpels just yet, but we are talking about algorithms that are able to analyze medical images
right.
and identify patterns and abnormalities that might be missed by the human eye.
So it's like a super powered assistant for doctors,
Yeah, that's a great way to put it.
especially radiologists, I imagine.
Exactly. Yeah. Radiologists are often dealing with a huge volume of images every single day.
Right.
And AI can really help to streamline that process.
So it's about efficiency, but it's also about accuracy, I'm guessing.
It's both. It's about being able to identify potential problems earlier. And it's also about being able to do it more efficiently.
So what kind of technologies are we talking about here? I mean, is this like machine learning? Is it natural language processing?
All of the above. We're talking about machine learning, we're talking about natural language processing, we're talking about optical character recognition even. All of these technologies are being used to analyze images like X-rays, CT scans, MRIs,
Got it.
and to extract meaningful information from them.
So these AI models they're trained on these massive data sets of images,
Exactly.
and they're able to sort of learn what to look for.
Right. They're able to learn the patterns that are associated with different conditions,
Right.
and they're able to identify those patterns even when they're very subtle or complex.
And imagine that's especially helpful for things that might be easily missed by the human eye.
Absolutely. The human eye can only process so much information,
Right.
and AI can really help to augment our abilities in that regard.
So it's like having a second opinion built right into the scanning process.
Yeah, that's a great way to think about it.
But I'm guessing it goes beyond just a second opinion. I mean, you talked about efficiency.
Yeah. Right.
I imagine this also has implications for things like cost reduction.
Absolutely. If you can identify problems earlier,
Right.
then you can often avoid more invasive or expensive treatments down the line.
And that's a huge deal in healthcare, obviously.
Huge deal. It's also about getting the right treatment to the right patient at the right time.
Right.
And AI can play a really crucial role in making that happen.
Okay. This all sounds incredibly promising so far.
Yeah.
But I'm guessing there are some challenges too, right?
Of course.
No technology is perfect.
Right. There are definitely challenges that need to be addressed. One of the biggest challenges is data quality and diversity.
Okay.
AI models need to be trained on massive data sets,
Right.
and those data sets need to be representative of the entire population.
So if a model is trained primarily on images from, say, a certain age group or ethnicity,
Right.
it might not be as accurate when analyzing images from patients outside of that group.
Exactly. And that could lead to misdiagnoses or inappropriate treatment recommendations.
Which is obviously a huge concern.
Huge concern. And then there's the whole regulatory landscape.
Right. Healthcare is a highly regulated industry.
It is. And AI software has to meet very strict standards in order to be approved for use.
So there's a lot of hoops to jump through.
There are. And then there's the challenge of integration.
Okay.
A lot of healthcare facilities are still using older systems.
Right.
And integrating AI into those systems can be a real challenge.
So making sure these systems can talk to each other is a big task.
It's a huge task.
Yeah.
And then, of course, there's the human element.
Right.
Healthcare professionals need to be properly trained
Of
to
course.
use these AI systems effectively.
So it's not just about plugging in a new piece of software. It's about changing the way we approach diagnosis and treatment.
Exactly.
All right, so we've got a pretty good overview of the landscape here. Let's maybe dive a little deeper into the tech itself. I'm curious, what does it actually take to build AI software for medical imaging?
Yeah, that's a great question. It's a very complex process.
Okay.
There are a lot of different components that have to come together.
Like what? Give me some examples.
One of the key components is image segmentation.
Image segmentation.
Yeah.
Okay, what's that? I've heard the term, but
Yeah, so imagine you have a CT scan of the lungs,
okay.
and the AI needs to focus specifically on a suspicious nodule.
Right.
Image segmentation is what allows the AI to isolate that specific area of the image
Got it.
so that it can be analyzed in more detail.
So it's like giving the AI a scalpel, but a digital one.
Exactly. And once you've segmented the image, you can do all sorts of interesting things with it.
Yeah.
You can measure the size of the nodule.
Okay.
You can analyze its shape and texture. You can compare it to other images over time to see if it's growing or changing.
That's incredibly useful.
It is. And then you have image registration.
Image registration. Okay, now I'm really curious, what's that all about?
So image registration is all about aligning and overlaying images
Okay.
that were taken at different times or from different angles.
Got it.
So, for example, if you have a before and after scan,
Right.
image registration can help you to see how a patient is responding to treatment
Oh, wow.
by allowing you to compare those images side by side.
That's super helpful.
It is. And it gets even more exciting when you start talking about 3D image registration,
Oh, wow.
where you're aligning and fusing 3D models of anatomy.
That's incredible.
It is. This is really revolutionary for things like surgical planning and
Right.
radiation therapy.
So all of this analysis, this is obviously taking a lot of computing power.
It does. We're talking about very complex algorithms
Right.
that require a lot of processing power.
So are we talking about like supercomputers crunching these images?
Well, not necessarily. One of the things that's really interesting about this field is that it's
Ah.
moving towards what's called life cycle automation.
Life cycle automation.
Okay.
What's involved in that?
So life cycle automation is all about using AI to streamline and optimize the entire imaging process,
The entire process.
from scheduling the scan to generating the final report.
Wow.
So this involves everything from automatically detecting and correcting image artifacts
Okay.
to ensuring that the images are properly labeled and stored.
Got it.
It can even involve using AI to prioritize urgent cases
Oh, wow.
and ensure that the most critical patients are seen first.
So it's really about improving efficiency across the board.
It is. It's about making things easier for radiologists.
Okay.
And it's also about improving data quality and consistency.
So it sounds like everything is kind of connected in this ecosystem.
It is.
But I'm curious, we've talked about identifying patterns and abnormalities, but what about extracting deeper insights from those patterns?
Right. That's where things get really interesting. We're talking about using AI to uncover hidden relationships in the data,
Okay.
to predict outcomes,
Uh-huh.
and to identify trends that might not be obvious to the human eye.
So it's about taking the data and turning it into actionable knowledge.
Exactly. Imagine being able to predict which patients are at highest risk of developing a particular disease
Wow.
based on their imaging data,
That's incredible.
or being able to identify new biomarkers that could help us diagnose diseases earlier.
That's amazing.
Yeah.
It feels like we're on the cusp of a whole new era of personalized medicine.
We are. And AI is playing a crucial role in driving that progress.
Okay, so let's talk about the brains of the operation then.
Yeah.
How do you actually choose the right machine learning model
Right.
for a specific task in medical imaging?
That's a great question. There's a whole universe of different machine learning models out there.
Okay.
And each one has its own strengths and weaknesses.
So it's like having a toolbox full of different tools.
Exactly.
And you need to know which tool is right for the job.
Right. Some models are better at image classification, others excel at segmentation,
Got it.
and still others are great at predicting outcomes.
So choosing the right model, or even combining multiple models, is crucial for getting the most accurate and insightful results.
Exactly. And the choice of model also depends on the specific type of imaging data you're working with.
So a model that works well for analyzing CT scans might not be as effective for MRIs or X-rays.
Exactly. The modality of the imaging data plays a huge role in determining which models are best suited for the task.
So there's a lot of nuance and expertise involved in making these decisions.
There is. And it's not just about choosing the right model. It's about training that model effectively,
Right.
using high-quality, diverse data,
Of course.
and then validating its performance rigorously to ensure that it's accurate and reliable.
So it's a complex process,
Is
but the results can be truly groundbreaking.
they can.
Yeah.
And we're only just scratching the surface of what's possible with AI and medical imaging.
I'm excited to dive into some of those possibilities with you. But first, I think we need to take a quick break.
Sounds good.
We'll be back in a few minutes to talk about how AI is being used in the real world.
Looking forward to it.
Stay tuned.
All right. It's pretty amazing when you think about it. We're already seeing AI being used in hospitals and clinics all over the world.
Yeah, it's really starting to make a difference in patient care.
Absolutely. One area where AI is really shining is in oncology.
Oncology. Okay.
Yeah, AI algorithms are being used to analyze mammograms, CT scans, and MRIs
Okay.
to detect early signs of cancer,
Wow.
often with greater accuracy than human radiologists alone.
So it's really helping to improve early detection.
It is. And early detection is key when it comes to cancer treatment.
Absolutely.
Yeah.
The earlier you catch it, the better the chances of survival.
Exactly. And it's not just about detection. AI is also being used to help oncologists plan more precise radiation therapy treatments.
Oh, wow. So it's improving both the accuracy and the effectiveness of cancer treatment.
Precisely. And it's not just cancer. AI is being used in cardiology to analyze echocardiograms and EKGs,
Uh-huh.
helping to identify heart abnormalities and predict the risk of heart attacks.
Wow. So it's having a really broad impact across different medical specialties.
It is. And what's really exciting is that AI isn't limited to big hospitals with massive budgets.
Okay.
We're seeing AI being integrated into smaller clinics and even primary care settings.
So it's really democratizing access to this technology.
Exactly, which is something I'm incredibly passionate about.
Me too. I mean, it's about leveling the playing field and ensuring that everyone has the opportunity to benefit from these advancements.
Absolutely. And it's not just about patients. AI is also having a profound impact on the work of radiologists themselves.
Okay, so let's talk about that. I know some radiologists are concerned about the potential for AI to replace their jobs.
Yeah, that's a valid concern.
So what's your take on that?
Well, I think it's important to remember that AI, at least in its current form,
Right.
is more likely to augment the skills of radiologists rather than replace them entirely.
Just about collaboration, not competition.
Exactly.
Yeah.
Think of AI as a powerful assistant, not a replacement.
Okay.
AI can help radiologists analyze images more quickly and efficiently,
Right.
identify potential issues they might have missed, and generate more detailed reports.
So it's like having a second set of eyes, but those eyes never get tired.
Right. And they can process information much faster than a human can.
And by freeing up radiologists from some of the more tedious and time-consuming tasks,
Right.
it allows them to focus on the things that require human expertise and judgment.
Exactly. Things like complex diagnoses and treatment planning.
So it's about elevating the role of the radiologist, not eliminating it.
Precisely. And in the long run, I believe this collaboration between humans and machines
Okay.
will lead to better patient outcomes.
So ultimately, it's about using technology to improve people's lives.
Absolutely. And we're only just scratching the surface of what's possible.
I'm excited to hear about some of those possibilities.
Yeah.
Where do you see this technology heading next?
Well, one area that's really fascinating is the emergence of real-time analysis and edge AI.
Real-time analysis and edge AI. Okay, break that down for me.
So imagine a portable ultrasound machine that can analyze the images as they're being captured,
Okay.
providing instant feedback to the clinician.
Wow, that's incredible. That could be revolutionary for emergency medicine.
It could. Think about a paramedic using an AI-powered ultrasound scanner in the field
Okay.
to quickly assess a patient with chest pain or abdominal trauma.
Right.
The AI could instantly flag potential issues like a collapsed lung or internal bleeding.
And that would allow for faster and more effective treatment.
Exactly.
Yep.
And it's not just about emergency medicine. AGI also has huge potential for remote patient monitoring.
Remote patient monitoring.
Yeah.
Okay, how so?
So imagine a patient with heart failure wearing a sensor that continuously monitors their heart rhythm
Okay.
and sends the data to an AI-powered platform.
Uh-huh.
If the AI detects any abnormalities, it could alert the patient's doctor,
Got it.
allowing for timely intervention and potentially preventing a trip to the hospital.
So it's about bringing healthcare to the patient rather than the other way around.
Exactly. And it's about empowering patients to take a more active role in managing their own health.
So we've got real-time analysis, remote monitoring. What else is on the horizon?
Well, how about 3D imaging and augmented reality?
Wow.
We're already seeing AI being used to create incredible 3D visualizations of anatomy.
Right.
But imagine those visualizations being integrated into AR headsets that surgeons can wear during surgery.
Whoa, so they could see a 3D model of the patient's anatomy superimposed over their actual body.
Exactly. It's like having X-ray vision, but with even more detail and precision.
That's mind-blowing.
Yeah,
It would be like navigating with a GPS, but for surgery.
it would. And it's not just surgery. This technology could revolutionize medical training,
Oh, wow.
allowing students to interact with virtual anatomical models in a way that's never been possible before.
It sounds like the possibilities are truly endless.
They are. And as AI continues to evolve, we can expect even more incredible breakthroughs in the years to come.
Well, I, for one, am very excited to see what the future holds.
Yeah.
But before we get too carried away with all the possibilities, I think it's important to take a step back
Yeah.
and address some of the challenges that come with this rapidly evolving technology.
Yeah, I think that's a great point.
I mean, no technology is perfect, and AI is no exception.
Right. We need to be thoughtful and responsible as we integrate this technology into healthcare.
So what are some of the challenges that we need to be thinking about?
Well, one of the biggest challenges is data privacy.
Data privacy.
Okay, we're talking about incredibly sensitive information.
Right.
Medical images, patient records, genetic data.
All being fed into these AI systems.
Exactly.
Mhm.
So how do we ensure that this data is being handled responsibly and ethically?
That's a great question.
Right.
I mean, it seems like there's a real tension there between the need for data to train these models and the need to protect patient privacy.
There is, and there's no easy answer, but there are some promising approaches being developed.
Like what? Give me an example.
Well, one example is federated learning.
Federated learning. Okay.
It's a technique that allows AI models to be trained on data from multiple sources
Okay.
without actually having to share the raw data itself.
So instead of all the data being centralized in one giant database, it stays distributed across different institutions.
Exactly. The AI model learns from each data set separately,
Mhm.
and then only the model's updates, not the raw data, are shared between institutions.
So it's a much more privacy-preserving approach.
It is. And it's just one example of the innovative approaches that are being developed to address the privacy challenges of AI in healthcare.
It's encouraging to hear that people are thinking about these issues so carefully.
They are. And it's not just about protecting individual privacy.
Yeah.
It's also about ensuring fairness and equity in the way AI is used.
Right. We need to make sure that these technologies are used to benefit everyone, not just a select few.
Absolutely. And that means being mindful of potential biases in the data that's used to train AI models.
Right, which we talked about earlier.
Exactly. It also means being aware of the potential for AI to exacerbate existing health disparities,
Oh, wow.
either intentionally or unintentionally.
So it's not just about the technology itself. It's about the social and ethical context in which it's used.
Precisely.
Hmm.
We need to make sure that AI is used in a way that aligns with our values and that it promotes justice and equity in healthcare.
Well said. So it sounds like we've got a lot of work to do.
We do, but I'm optimistic.
Okay.
I think AI has the potential to revolutionize healthcare for the better,
Huh?
but we need to make sure that we do it right.
It's a balancing act.
It is, but it's a balancing act that I think we're up to.
I agree. Okay, so we've covered a lot of ground today, from the technical details of AI algorithms to the ethical considerations of using this technology in healthcare.
It's been a fascinating conversation.
It really has.
Mm.
But before we wrap up this episode, I'm curious to get your take on one more thing.
Sure.
You know, we've talked about how AI is already changing healthcare.
Right.
But what about the future? What are some of the biggest challenges and opportunities that you see on the horizon?
That's a great question. One of the biggest challenges I see is the need for greater transparency and explainability in AI systems.
Transparency and explainability, okay.
As these systems become more complex,
Right.
it's becoming increasingly difficult to understand how they're arriving at their decisions.
So it's not just about getting an answer from the AI.
Right.
It's about understanding the reasoning behind that answer.
Exactly. If a doctor is going to make a treatment decision based on an AI recommendation, they need to be confident that they understand how the AI arrived at that recommendation.
That makes sense.
Yeah,
I mean, you have to be able to trust the AI's judgment.
you do. And explainable AI is crucial for building that trust.
Okay.
It's about creating AI systems that can provide clear, understandable explanations for their decisions,
Got it.
so that doctors and patients can feel confident in the guidance they're receiving.
So it's not just about developing powerful AI algorithms.
Right.
It's about making those algorithms understandable, and trustworthy.
Exactly. And that's a challenge that researchers and developers are actively working on.
That's good to hear.
Yeah.
But even with explainable AI, there's still the question of human oversight.
Right.
I mean, do we want AI making life or death decisions on its own?
Yeah.
Or should there always be a human in the loop?
That's a crucial question,
It is
and one that doesn't have an easy answer.
right. There are strong arguments to be made on both sides.
There are. On the one hand, AI has the potential to make decisions more objectively and consistently than humans,
Okay.
potentially reducing errors and biases.
So in some situations, AI might actually be the safer option.
It's possible, but on the other hand, there's always the risk of unforeseen consequences of the AI encountering a situation that it hasn't been trained for and making a decision that could harm a patient.
So there's a need for a balance between leveraging the power of AI
Right.
and ensuring human accountability.
Exactly. We need to find a way to harness the benefits of AI
Right.
while still maintaining human oversight and control.
It's a delicate balance for sure.
It is, and one that we'll need to continue to grapple with as AI technology advances.
Well, it's clear that AI is going to play an increasingly important role in healthcare in the years to come.
I agree.
But it's also clear that we need to approach this technology with caution and careful consideration.
Absolutely. AI has the potential to transform healthcare for the better,
Right.
but we need to make sure that we use it wisely and responsibly.
Well said. Well, this has been an incredible journey through the world of AI in medical imaging. I feel like I've learned so much about the technology, the applications, and the ethical considerations that come with this rapidly evolving field.
It's been my pleasure sharing my insights with you and your listeners.
And a huge thank you to Scopic for providing the information that made this deep dive possible.
Absolutely. They're doing some amazing work.
So as we wrap up this episode, I'm left with a sense of both excitement and responsibility.
Yeah.
Excitement for the incredible potential of AI to improve healthcare,
Right.
and responsibility for ensuring that we use this technology in a way that benefits all of humanity.
I think that's a perfect way to put it.
Thanks for joining us on this deep dive. We'll see you next time.
It is a balancing act.
Yep.
And one area where that balance becomes really crucial is in data privacy.
Oh, yeah, for sure.
We're talking about incredibly sensitive information. Medical images, patient records, genetic data. All of this stuff is being fed into these AI systems.
And that's a lot of really personal information.
It is. So how do we make sure that it's being handled responsibly and ethically?
Yeah, that's a big question.
Yeah.
I mean, how do we protect patient privacy while still allowing these AI models to learn and improve?
Well, that's where things like federated learning come in.
Federated learning.
Mhm.
Okay, I've heard that term, but I don't really know what it means.
So federated learning is a technique that allows AI models to be trained on data from multiple sources
Hi.
without actually having to share the raw data itself.
So instead of all the data being centralized in one giant database,
Right.
it stays distributed across different institutions.
Exactly. The AI model learns from each data set separately,
Uh-huh.
and then only the model's updates, not the raw data, are shared between institutions.
So it's kind of like the AI is traveling to the data instead of the data traveling to the AI.
That's a great way to put it. It's a much more privacy-preserving approach.
That's fascinating. It sounds like a really elegant solution to a complex problem.
It is. And it's just one example of the many innovative approaches that are being developed to address the privacy challenges of AI in healthcare.
That's really encouraging to hear.
Yeah, and it's not just about protecting individual privacy.
Okay.
It's also about ensuring fairness and equity in the way that AI is used.
Right. We need to make sure that these technologies are used to benefit everyone, not just a select few.
Exactly. And that means being mindful of potential biases in the data that's used to train AI models, as we talked about earlier.
Right.
It also means being aware of the potential for AI to exacerbate existing health disparities, either intentionally or unintentionally.
So it's really about being thoughtful and intentional about how we develop and deploy these technologies.
It is. We need to make sure that AI is used in a way that aligns with our values and that it promotes justice and equity in healthcare.
Well said. Well, this has been an incredible deep dive into the world of AI and medical imaging. I feel like we've covered so much ground today.
We have.
From the technical details of image segmentation to the ethical complexities of data privacy and algorithmic bias.
It's been a real pleasure sharing my insights with you and your listeners.
Well, it's been a pleasure having you. And a huge thank you to Scopic for providing the information that made this deep dive possible.
Absolutely. They're doing amazing work in this field.
So as we wrap up this episode, I'm left with a sense of both awe and responsibility.
Yeah, me too.
Awe at the incredible potential of AI to improve healthcare,
Uh-huh.
and responsibility for ensuring that we use this technology wisely, ethically, and for the benefit of all.
I couldn't have said it better myself.
Well, thanks for joining us on this deep dive.
Oh.
We'll see you next time.